Most people, when they think of a large excavator, picture a machine digging downward. The boom reaches out and up. The stick hangs down. The bucket faces back toward the machine. It digs by pulling the bucket through the material, by drawing material up and back in a curling motion. This is the backhoe configuration. It is the most common excavator configuration in the world, from construction sites to the largest surface mines. But there is another way to dig. You can push the bucket forward into the material rather than pulling it back. You can approach the face head-on, driving the bucket teeth directly into the rock, loading material by crowding forward rather than by dragging back. You can use the machine's weight and the full force of its hydraulic system in direct forward thrust. This is the face shovel configuration. And at the scale of the Caterpillar 6090 FS, it produces a machine with incredible capabilities. The Cat 6090 FS is one of the largest hydraulic face shovels ever built. Its bucket capacity reaches 52 cubic meters in standard configuration. Its operating weight exceeds 1,000 metric tons, making it one of the heaviest mobile machines in the world. Its face-digging configuration gives it advantages in hard rock applications that make it the choice in the world's most demanding mining environments. But before the engineering details, we need to understand the history. This machine did not spring fully formed from Caterpillar's engineering department. It has a lineage that begins with a German company, passes through a significant corporate acquisition, and arrives at American manufacturing scale. The story begins with O&K, a German engineering company building mining equipment since the late 19th century. O&K developed large hydraulic face shovels in the 1990s. When Bucyrus acquired O&K's mining division in 1997, the RH400 came with it. And when Caterpillar acquired Bucyrus in 2011, everything came with it, including the engineering heritage and the pipeline that produced the 6090 FS. The 6090 FS is the product of German precision engineering tradition, refined through transitions and scaled up by American manufacturing capability. Understanding this heritage helps explain why the machine performs the way it does. The face shovel's advantage in hard rock is real and significant. It requires understanding why the direction you dig matters, and why, in certain conditions, pushing forward is better than pulling back. When a backhoe excavator digs into a rock face, the bucket enters the material at an angle, typically from above and side, pulling toward the machine. The force available is a function of hydraulic cylinders and arm geometry. At maximum crowd force, backhoe geometry works against maximum achievable force application. A face shovel digs differently. The bucket faces forward. The stick pushes directly into the face horizontally in the direction the machine is facing. The crowd force is applied in direct alignment with the bucket's travel. There is no angular inefficiency. The full force translates into bucket penetration. The crowd cylinder in the Cat 6090 FS generates forces allowing the bucket to penetrate competent rock that backhoes of comparable size would struggle with. This direct force application gives the face shovel a specific advantage in hard, blocky rock found in copper, gold, and iron ore mines. A face shovel can often load coarser fragmentation effectively because its crowd geometry allows it to push through or around larger fragments. The face shovel also has an advantage in bench geometry. It can work very close to the face, touching it with the front undercarriage. This tight approach allows for deep, productive cuts. Fewer repositioning moves mean more time digging and more productive efficiency. The 6090 FS has a bucket capacity of 52 cubic meters, larger than the Liebherr R9800. It fills a 363 metric ton truck in just 3 passes. In hard rock applications, this achieves loading with less blasting preparation, a cost saving that can be substantial for mining operations. The operating weight exceeds 1,000 metric tons. This mass is a feature used to resist reaction forces when pushing into the face. A light machine would simply push itself backward. The 1,000-ton mass of the 6090 FS is the anchor for its immense hydraulic crowd forces, but the hydraulic system that powers those forces, emerging from the rock with a full 52 cubic meter bucket, is the most impressive engineering achievement. The CAT 6090FS is powered by two diesel engines, a configuration similar to the Bell AZ 75710 and reflecting the same logic. No single commercially available diesel engine produces sufficient power for a machine of this class in a package that fits the installation space available. Two engines, each producing approximately 1/600 horsepower, provide a combined output of approximately 3,200 horsepower. These engines drive hydraulic pumps, large, high-pressure axial piston pumps that generate the hydraulic flow that powers every working function. The hydraulic system pressure reaches approximately 350 bar, the same operating pressure as the Liebherr R9800 and the Bucyrus RH400. The crowd and lift cylinders generate forces measured in hundreds of tons, cycle after cycle, for thousands of operating hours. The crowd cylinder is the most heavily loaded component. It must push the bucket teeth through rock while controlling the stick's velocity. Proportional hydraulic valves respond to operator inputs with millisecond precision, translating lever movements into precisely calibrated hydraulic flow. The swing system rotates the upper structure. The mass being swung is substantial: the boom, stick, bucket, and their combined full payload. Stopping it precisely for accurate dump placement requires careful calibration. Too aggressive and it overshoots. Too conservative and cycle time suffers. The cooling system manages heat from two engines' worth of pump output. At maximum output, the heat rejection requirement is extreme. The undercarriage supports the machine's 1,000-plus ton weight. Its track components are subject to constant load cycling and abrasive wear. In hard porphyry copper rock, the 6090FS achieved loading rates that exceeded the performance of backhoe excavators of comparable size. The face-digging geometry delivered the crowd force advantage predicted. Structural robustness proved the design addressed fatigue challenges in hard rock. This success has influenced how copper mines design blasting programs and allocate capital. More options lead to better decisions for mine planners. The CAT 6090FS has been deployed in copper mines in Chile, Peru, and Zambia, in gold mines in West Africa and Australia, in iron ore operations in Brazil and Western Australia. In each case, the machine was selected because the rock hardness and production volume requirements aligned with the face shovel's strengths. At the Chuquicamata copper mine in Chile, one of the largest open-pit copper mines in the world, 6090FS units work alongside other large loading equipment in conditions that test every aspect of the machine's design. The Chuquicamata rock is hard, the altitude is high, over 2,700 meters above sea level, and the production targets are substantial. At high altitude, engine performance is reduced by the lower air density. Caterpillar addresses this with high-altitude engine configurations. Every large diesel-powered machine working at the high-altitude mines of the Andes faces the same power reduction from reduced air density. Managing this reduction through maintenance practices that keep engine systems in peak condition is one of the operational disciplines. For the 6090FS, maintaining adequate power requires careful attention to turbochargers, intercoolers, and air filtration systems. In Australian iron ore applications, the Pilbara region, the 6090FS works in a different set of conditions. The material is extremely hard and abrasive. The climate is extreme, hot, dry, and dusty, and the production volumes are enormous. The face shovel configuration performs well where rock hardness favors crowd geometry over the backhoe's pulling geometry. Structural fatigue has been managed through the structural design choices built into the 6090FS. Component life, particularly in the high-wear items of the undercarriage and bucket teeth, matches or exceeds expectations. Fleet management benefits from Caterpillar's product-linked telematics system, providing real-time visibility into machine status. Mine management teams can see which machines are producing at target rates and which have developing maintenance issues. This visibility allows proactive management of the excavator fleet, maximizing productive utilization and minimizing unplanned downtime. The CAT 6090FS represents one of two mature hydraulic excavator configurations available at the highest production scales: face shovel and backhoe. Both configurations have permanent places in large-scale surface mining. The choice depends on rock hardness, fragmentation characteristics, and specific productivity metrics. The 6090FS has reached a level of hydraulic sophistication that allows it to compete with the best rope shovels in hard rock applications. Advantages in flexibility, faster repositioning, and better low-volume economics have made it a genuine alternative to rope shovels in previously unchallenged markets. Caterpillar continues to develop the platform with ongoing improvements to electronic control systems, fuel efficiency, and structural design. The acquisition of Bucyrus brought engineering talent who spent careers developing ultra-large hydraulic excavators, bringing that expertise to Caterpillar's process. The 6090FS of today reflects that combined expertise, and the future will reflect the continued evolution of that engineering power. The face shovel configuration, pushing forward into the face, was an approach used for over a century before hydraulic technology was applied. The CAT 6090FS is the current state-of-the-art in that ancient tradition, pushing straight into material until the bucket is full. Next, we move to the P&H 4100 XPC, the largest electric rope shovel in production, taking the rope shovel tradition to its modern limit. A machine whose dipper tears through rock that challenges hydraulic excavators, refined through a century of continuous development. Its engineering story shows how an old technology remains at the frontier of productivity in the hardest conditions surface mining presents. The numbers are extraordinary, the history is extraordinary, and we are just getting started.